Okay, today we're going to look at section 3.2, synthetic division. We're going to do division using synthetic division. If we divide f of x by d of x, we write our answer as f of x over d of x equals q of x plus r of x divided by d of x in fractional form, or f of x equals d of x times q of x plus r of x in polynomial form, where q of x is the quotient and r of x is the remainder. So this is just like long division from way back in elementary school. So to start off, we'll rewrite this, if I remember to turn on my pen, as x plus 1 goes into x cubed minus 5x squared plus 3x minus 2. The first thing we need to remember when doing this is make sure that if you have a third degree term, you have a second degree term, a first degree term. If you do not have one, put 0. So if there was no x squared terms, I would write this with 0x squared. So here's what we do. We look at this first figure here and this figure here. What can I multiply by x to get x cubed? Well, x squared will do the trick. So x squared times x gives me x cubed, and x squared times 1 gives me x squared. Now, what I do, just like in long division, subtract all of this. So what happens is, of course, the x cubed minus x cubed cancels out. So I get 0, and here I have 5x squared minus x squared, which is minus 6x squared. I bring down my next term, 3x. Okay, now what times x will give me negative 6x squared? And that is simply negative 6x. So I go through, negative 6x times x is negative 6x squared. Negative 6 times 1. Negative 6x times 1 is minus 6x. And again, I'm subtracting the whole thing. So here I get 0. Here I get 9x, and I bring down this negative 2. Now x times 9 will give me 9x. So I have 9x plus 9. Again, subtract this, and I get minus 11. So my remainder is minus 11. So I have 11 over x plus 1. So my answer is x squared minus 6x plus 9 minus 11 over x plus 1. Looking at this, q is equal to x squared minus 6x plus 9, and r, or q of x, we'll call it, q of x is equal to x squared minus 6x plus 9, and r of x is equal to 11. Okay, so let's look at another one. Here we have a fraction, same thing, x minus 4 into x to the 4th plus 2x to the 3rd minus 3x squared. We don't have an x term, so we just put plus 0x plus 1. So now x times x cubed gives me x to the 4th, and then we have minus 4x cubed. I subtract all that. This gives me 6x cubed. Bring down my 3x squared plus x times 6x squared gives me 6x cubed, and this gives me minus 24x squared. Again, subtract it all. Now I have 21x squared plus 0x. Well, this is 21, right? Plus 21 gives me 21x gives me 21x squared minus 84x. Add 80, or subtract again, and I get 84x plus 1, bringing down the 1. So I get plus 84. And here I get 84x minus 336, which when subtracted gives me 337. So plus 337 over x minus 4. And that is my solution. So we have x cubed plus 6x squared plus 21x plus 84 plus 337 over x minus 4. That is our answer. Okay. Okay, now we're going to look at this a little differently. We're still going to do the same thing. We want to factor out x minus 2, or x minus k, where k is -2. So that becomes x plus 2. So that simply means we're going to divide by x plus 2. So again, 5x cubed, 6x squared minus 28x minus 2. So we have 5x squared. Oops. 5x squared, which gives me 5x cubed plus 10x squared. Subtracting, we get negative 16x squared. Bring down our negative 28x. So minus 16x, we have minus 16x squared minus 32x. We do the subtraction and we get 4x minus 2. Then we add plus 4 and I get 4x plus 8. And again, subtracting that, I get 10. So in this case, q minus 10 over x plus 2. Q of x equal to 5x squared minus 16x plus 4, and r is equal to, let me be sure, the remainder, which is just 10, or negative 10. So when we put this together, we have f of x equals x minus 2, which is, or x minus k, which is x plus 2, times q, 5x squared minus 16x plus 4 minus 10. Okay, same thing here. We want to find x minus k, so k is 4. So I have x minus 4, x cubed plus 8x squared plus 0x plus 63. Again, x squared gives me x cubed minus 4x squared. Subtracting it all, I get 12x squared, bring down my 0x. So here is plus 12x. I get 12x squared minus 48x. Subtracting again, I get 48x plus 63. Now here I have plus 48 gives me 48x minus 192. Again, subtracting, I get 255. So again, f of x in this form is equal to x minus 4 times x squared plus 12x plus 48 plus 255. That's what I'm looking for. If a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. So let's see what happens. So k is 5. So we're dividing by x minus 5. Yep, let's leave us some room. Let's do this over here. X minus 5 goes into x squared minus 4x minus 5. So we have x, which gives me x squared minus 5x. Subtracting that, I get x minus 5. So I get plus 1. X minus 5 gives me a remainder of 0. So what is f of 5? Well, it's 5 squared minus 4 times 5 minus 5, which is 25, minus 20 minus 5, which is 0. So it appears to work. So now I have k equals -3, so I'm looking at x plus 3 goes into 2, x cubed minus 2 minus 3x squared minus 5x plus 4. So here we have 2x squared gives me 2x cubed plus 6x squared, subtracting negative 9x squared, bring down my negative 5x. Negative 9x gives me negative 9x squared minus 27x. Subtract again, I get 22x plus 4. That give me plus 22. Give me 22x plus 66. Give me negative 62. So what is f of -3? Now it's 2 times -3 cubed minus 3 times -3 squared minus 5 times -3 plus 4. Well, -3 cubed is -27, and this is -54. Might have an error here somewhere. This is -27, positive 15 plus 4. So this is -81 plus 19, which is -62. So we are good. Check. That is an interesting piece of information. Okay, so now we talk about a zero of a polynomial function is a number k such that f of k equals 0. We can also determine if k is 0 by using synthetic division to determine if the remainder is 0. So use synthetic division to decide whether the given number k is a 0 of the given polynomial function. If not, give the value of f of k or the remainder. So we're going to use synthetic division. K equals 1. So we have x minus 1 goes into 2x cubed plus 9x squared minus 16x plus 12. If we get a remainder of 0, 1 is a 0. So here we have 2x squared gives me 2x cubed minus 2x squared. Subtracting everything gives me 11x squared. Bring down my minus 16x. So here plus 11x gives me 11x squared minus 11x. Subtracting all that gives me negative 5x plus 12 minus 5 gives me negative 5x plus, oops, minus 5. No, plus 5. Which gives me a remainder of 7. So this is not a 0. Just to test it, let's do f of 1. 2 times 1 cubed plus 9 times 1 squared minus 16 times 1 plus 12. Well, this is just 2 plus 9 minus 16 plus 12. 11 negative 5 equals 7. So no, it is not a 0. Okay, now I have k equals negative 5. Now I have x plus 5 goes into x squared plus 4x minus 5. So x goes into x squared. We have x, which gives me x squared plus 5x. Subtracting all this, I get negative x minus 5. So I have negative 1, which gives me negative x minus 5, which gives me 0. And again, we can test this. F of negative 5 is equal to negative 5 squared plus 4 times negative 5 minus 5. 25 minus 20 minus 5, which equals 0. Okay, so that apparently is all the examples for this. So that is it for this section. Have a good night.